Today we are going to look at the three states of matter using H2O molecules. We will first begin with ice. Which of our three states of matter is our H2O molecule in? Solid, liquid, or gas? Well, I know that a liquid is fluid, and this doesn't seem very fluid. And I know that a gas tends not to stay in its container. I'm thinking that this is a solid. If you look here, we have little gaps in between because a solid does not take the shape of its container, it keeps its own shape. Therefore, I think that the state of matter for ice is solid. Please record that on your student data sheet. All right, let's measure the ice's temperature. I don't want to just say that it's freezing, so I'm going to use my thermometer to get an accurate reading in degrees. So we're gonna put our thermometer down in here. See how we're gonna shimmy it in. Boop. Just gonna kind of push some of my ice over there. And we will wait to get an accurate temperature. I can already see the little red line on my thermometer dropping down lower. It started at 80, but I know that since I have ice, it's much colder than that. We'll just give it a minute. Slowly but surely. All right, looking at the top of the red line to get our temperature, I can see that it's at about 32 degrees Fahrenheit, which is our freezing point. Now, if we're gonna look at our volume, the beaker that I have the solid in has little increments on the side, just like a graduated cylinder, and it's measuring in milliliters, so it's going to measure the volume. At the very top here, it's kind of hard to see because the ice is in the way. At the very top, we hit 80, and our next line down is about 70. So our ice hits perfectly at 70 milliliters.
In order to turn our solid H2O molecule into water, we need to heat it up. So I'm going to use a hot plate to heat our ice until it turns into water. So we're going to put it on the hot plate and heat it up. So now we're starting to notice that the state of matter for water is turning from the solid into a liquid, and it's going to have a fluid movement and take the shape of its container, which means that it is now going to be a liquid. So we're going to let that heat up for a little bit. So we see now that all the ice has melted and it's now completely a liquid. And we're gonna measure the temperature of our water next. And I want you to notice that we're not touching that hot container. We're using a safe material to move it. So we are gonna stick our thermometer back into the beaker and record the temperature.
Maybe. Oh. All right, the line shot straight up to 100 degrees Fahrenheit.
So as you can see, we heated up that water. Now it is 100 degrees, so you can go ahead and record that on your sheet. Next, we're gonna check our volume. So remember, this is the same H2O molecules that we had in the solid state. We didn't add and we didn't remove any water. So our volume is at 40 milliliters. So you can go ahead and record that also on your sheet, 40 milliliters.
so now to take water from a liquid state and turn it into water vapor, we need to keep heating it until we see steam. So we're gonna go ahead and put this back on the hot plate, remembering to use our safety mitt so that we don't burn our hands. And we are going to heat it up until it brings us to our third state of matter, gas. So we're just gonna give it a minute to heat up to that point. All right, as you can see, our liquid is now bubbling profusely. And I don't know if you can see it from the back here, but you can kind of see the steam rising up and catching on the edge of the glass. So we're gonna go ahead, now that we have some of our water vapor being created, we're gonna go ahead and remove it and take the temperature of the water vapor. And we'll stick our thermometer inside. I'm gonna tell you right now, it's gonna be real hot. I'm not gonna stick it all the way in there because I have broken a thermometer before. So our temperature has reached past 120 degrees Fahrenheit. So in order to record it, our thermometer only goes up to 120. So on your recording sheet, just put greater than 120 degrees Fahrenheit. And then we'll remove. And we're gonna look finally at our volume. So you can see over here, we were at exactly 40 when we had it in liquid form. And so in order to take the volume of a gas, we need to take our starting liquid point and subtract what's left after we created the water vapor. So we started at 40 and now we have a little bit less than 40. So at this mark down here, that would be 30. About halfway between would be 35. So I'm gonna estimate that we're at about 36 or 37. So we take 40 minus, let's say 36. Our water vapor's volume is 4 milliliters. Go ahead and record that on your sheet.